Welcome everybody. I want to take a minute here to talk briefly about solubility curves. This portion right here of your notes, this graph right here is showing solubility curves of several different compounds. Now, at first glance, it looks chaotic. It looks like a mess because there are lines all over the place. But if you just break it down and look at one line at a time, each line has a specific compound associated with it. So each line is representing a particular compound. Now, you just need to follow that line from point A to point B to understand if it's an increasing curve, a decreasing curve, is it a solid, is it a gas, and so forth. So I'm going to talk briefly about how to understand and interpret these graphs. There's also an Edpuzzle video that's posted on Google Classroom that will help explain these concepts a little bit more. So one of the things that you should know or see already here is that on the y-axis you have the grams of solute per 100 grams of water. Okay, so that's kind of important. And then down here on the x-axis you're measuring temperature. So you can see if you pick any line, let's say sodium nitrate, it starts here at approximately 72 grams and increases all the way to the maximum that this graph allows, which is, I would say, maybe 150 grams, all while the temperature is increasing. Okay, so as I move to the right on my x-axis, the temperature is increasing, and as I go up the y-axis, the mass of the solute is increasing as well. So one of the things that you're going to be asked to figure out is to determine the solubility of certain substances at certain temperatures, because temperature affects the rate at which solutes can dissolve into a solution, depending on if it's a solid, a liquid, or a gas. So here it says determine the solubility of sulfur dioxide at 60 degrees Celsius. So I'm going to just zoom in here so you can get a better look at it. There we go. All right, so sulfur dioxide is right here, SO2. Okay, so this is SO2, and I want to figure out the solubility of sulfur dioxide at 60 degrees Celsius. So I'm going to come over here on the x-axis and find 60 degrees. All right, 60 degrees is right there. Now, I need to be able to identify my line. So I'm going to go ahead and highlight the line just so you're aware of which one we're looking at. So sulfur dioxide at 60 degrees. So I want to figure out the solubility of sulfur dioxide at 60 degrees Celsius. So all I need to do is find where 60 degrees and the line for sulfur dioxide meet. Let me try to draw a better point here. All right, so this is where 60 degrees meets sulfur dioxide, and if I follow this line all the way to the y-axis, and my line is not very straight, let me try that again. That's slightly better. It looks like it might be about 4, maybe 5 grams. So let's go ahead and fill that in. The solubility of sulfur dioxide at that temperature, I would say somewhere between 4 to 5 grams. So now I want to take a look at a different compound. I want to look at potassium nitrate at 45 degrees Celsius. So you got to think about what is the formula for potassium nitrate. Well, I know it has to be somewhere in this graph. And I know potassium is a K, nitrate is NO3. So I find KNO3, this is potassium nitrate. So what I'm going to do is I'm going to go ahead and highlight that line just so that there's less confusion. KNO3, there we go. Okay, so now I've identified where KNO3 is. on my graph, and the question says determine the solubility at 45 degrees. All right, so let me zoom in here a little bit for you. So let's find 45 degrees. Temperature, here's 40, here's 50. 45 degrees is probably going to be right here in the middle. Okay, so I'm going to go up 45 degrees, and then I'm going to look across my y-axis, and it looks like, and again, my line's not very straight, but I would say this point's probably about 74, maybe 75 grams. So the solubility of potassium nitrate at 45 degrees, probably going to be, let's say, 74 to 75 grams. At which temperature do sulfur dioxide and potassium nitrate have the same solubility? So anytime you're asked to find the same, or where are they the same solubility, you're looking at where the lines intersect. Can't write today. Let's try that again. There you go. Where the lines intersect. Okay, so I want to find sulfur dioxide and potassium nitrate. So I'm going to go ahead and let's see if I could zoom in here for you. We've already highlighted potassium nitrate. Let's re-highlight sulfur, what was it, sulfur dioxide? Yeah, sulfur dioxide. Okay, so now I want to look at where those lines intersect. So when I find the intersection, it looks to be right there. When I follow that along to the y-axis, it looks like it's approximately close to 20 grams. But the question is asking you what temperature. So that means I'm looking at my x-axis. And it looks like approximately, let me try to draw that line a little bit better. There. So it looks like it's slightly more than 5. I would say maybe 6 or 7 degrees Celsius. So let's say, I'll say between 6 and 7 degrees Celsius is where their lines intersect. So that's the point where they have the same solubility. Here and figure out which one of these are gases. Well, we know that solids dissolve more as the temperature increases, but gases have the opposite effect. So as the temperature increases, the solubility of a gas actually decreases. So in order to find out which one of these are gases, you're looking for the ones that have a negative slope. All right, so I'm looking at potassium iodide, positive slope, sodium nitrate, positive slope, KNO3, positive slope. So you're looking for ones that have negative slope. So I see a line here. Let me try to highlight that for you. There's a little line here that's got a negative slope. This line here has a negative slope. This line here has a negative slope. And I think those are the only 3. Every other line that's in here has a positive correlation, meaning it's going up. It's got a positive slope. So my 3 gases in here are hydrochloric acid. I'm sorry, hydrogen chloride, ammonia, and sulfur dioxide. So those are my 3 gases in my solubility curve. Let's move on. It says use your knowledge here of solid versus gas solubility. Can you determine which compounds in the graph above are gases? So let's look. Let's go back. All right. So it was HCl. It was NH3. And it was SO2. And I know they're gases because their solubility decreases with temperature. So solubility decreases with an increase in temperature. So as temperature rises, the solubility of gases decreases. In other words, they have the negative slope. So your lines have a negative slope. Easiest way to determine that. All right. Moving on to the last page here is interpretation of the solubility graph. Okay, so you talked about, or you've looked at, hopefully, 3 types of saturation or solubility. There's saturated, unsaturated, and supersaturated. So let me zoom in a little bit for you. All right, so an unsaturated portion of the graph is indicated by the area below the line, meaning I can still dissolve more solute into that solution. A saturated solution refers to a point that is on the line, and a supersaturated is a point that is above the line. So you can be either below a line, on the line, or above the line. So unsaturated is below the line. If you're on the line, it's saturated. If you are above the line in the graph, it is considered supersaturated. All right, so let's look at a couple questions here. The question number 1A says, determine if the following is unsaturated, saturated, or supersaturated. So we got to look at the position of the point on the graph in relation to the compound line that we're looking at. So A says 70 grams at 90 degrees of ammonium chloride. So I'm going to zoom in here on the graph. Ammonium chloride. So I need to find ammonium chloride. Let's see. Ammonium chloride. NH4Cl. Here's my compound. So I'm going to go ahead and highlight that line so you can see it a little bit better. There's ammonium chloride. Now the question says 70 grams at 90 degrees Celsius. Okay, so the easiest thing for me is to start with temperature. I like starting with the temperature first. So I'm going to come across the x-axis and find 90 degrees. There's 90 degrees. Okay, so 90 degrees and 70 grams. So 70 grams is up here on the x-axis. So now I need to figure out where 70 grams and 90 degrees intersect. So if I go across here, 70, and up at 90, I notice that this is where they intersect. And they intersect on the line of ammonium chloride. So if it intersects on the line, then that's telling me that it is a saturated solution. Okay, so the next one is 60 grams at 30 degrees Celsius of sodium nitrate. So now I want to zoom in back on the graph and find sodium nitrate. Sodium nitrate. Sodium nitrate, NaNO3. Here's sodium nitrate. So let me highlight this for you. Sodium nitrate, I'll highlight in red. NaNO3. All right, so it says 60 grams at 30 degrees Celsius. So I want to find 30 degrees Celsius and 60 grams. So now I need to figure out where those intersect. So 60 grams, 30 degrees. Here is where they intersect. All right, so now I notice that here's the point where they intersect. Here is my sodium nitrate line. This point is below the line, which means that there's a lot more room for me to dissolve more substances or more solute into my solution Therefore, this point is below the line. This is an unsaturated solution. So let me go and fill in the blank. This is unsaturated. All right, and the last one here, 60 grams at 30 degrees potassium nitrate. So I'm going to come back up to the graph, find potassium nitrate. All right, potassium nitrate. Here it is, KNO3, potassium nitrate. So I'm going to go ahead and highlight that one. All right, potassium nitrate. Okay, and the question says 60 grams at 30 degrees. So I'm going to find my temperature, 30 degrees, 60 grams, and I'm going to figure out where those intersect. So here is their intersection point. Now, you'll notice that here is 60 grams, 30 degrees. Here is my line. So this point of intersection is above my line, which means this is a super saturated. All right, so it is super saturated because it is, let me fill this in, above the line. Unsaturated means it is below the line. And saturated means it's on the line. All right, and the last one here, how much more solute can be dissolved into potassium nitrate solution that contains 60 grams of solute at 60 degrees? So I want to find potassium nitrate first. So I'm going to come back up here. Potassium nitrate is already highlighted for me, so let me clear some of these markings. Apparently it's not going to let me. Okay, so let me re-highlight that line. Potassium nitrate. Okay, so it says how much more solute can be dissolved if the solution contains 60 grams at 60 degrees. So 60 grams, 60 degrees. All right, here's where I'm at. Now, the question says how much more can be dissolved. So you notice that this point of intersection here is below my line, so this is unsaturated, which means I can still dissolve more solute into my solution. So I need to figure out how much more can I actually dissolve at this temperature. So I want to figure out how much room I have left. So all you're doing essentially is counting. If this is 60 and I'm in increments of 10, then I can go 10, 20, 30, 40 more approximately. 40 more grams can be dissolved at this temperature to get me saturated. So 40 grams is my answer. So we'd say 40 additional grams can still be dissolved.